Basic architecture features a programmable DSP device should be provided instructions similar to conventional microprocessor. So the features of architecture. Actually, previously we seen the basic block diagram of DSP architecture. Here the features of architecture. The first one is arithmetic operation. So we know that what is arithmetic operation such as add, subtraction, and multiplication, and logical operations and are not XR, and multiply the accumulate, that is a MAC operation, and signal scaling operation. The addition to the above prevision, that architecture should be also include on-chip register, unchip memories that store so signal samples RAM and ROM. So unchip memory stores file in coefficients. So these are the features are present in DSP application. So DSP computational building blocks. So in that, the basic architecture they have data register and also multiplier, ALU, and shifter. So the multiplier, that's the main advance in single chip multiplier paired with the way of implementation of DSP function on a VLSI chip, and parallel multiplier replace the traditional shift and add multipliers are nowadays. Also the multipliers having that accuracy, dynamic range, and speed. Okay, then the parallel multiplier. Here we are using digital multiplier. So digital multiplier, that is nothing but so bond multiplier is basic bond array multiplier. Also the name we can call as a parallel multiplier. So the parallel multiplier, this is a basic operation. That's a operand, and see that multiplier and multiplication is there. So just we add it, and this is a place we can add and put the result of the product. And this total place, this is add place. Here you can indicate, you can use indicate, and this is the place is R, so you can use R gate like that. So you have to use this structure is a array multiplier or parallel multiplier. So this is a product of multiplier. So finally you will be get the value. So for example, this is a 4 cross 4 multiplication bond multiplier. So same structure they given. So bond multiplier 4 cross 4. So 4 cross 4, and then the result will be getting like that. Shifter. So shifter is used to either scale down and scale up operands on the result. The following scenario the given necessary of the shifter. So what is shifter? So it will be shifted the data one place to another place or one register to another register. So it can used to left shift or right shift like that. Also, it is used to shifter is above. That shifter required to required that architecture in DSP. So the floating point number one of the operand has to shift it apparently to make exponent of the two numbers equal. So the arithmetic logic. So we know that and operation add, are not, XOR. So logic function. Uh, so arithmetic means add, subtraction, multiplication, the increment, decrement. So this is an arithmetic operation, and logic operation and are not XOR. These are the logic operations. So both are combined. That is ALU. So ALU, this is a basic block diagram. So register, mux. So the data is there, accumulator is there, and status flag. So whether what kind of status they have, the carry having, it is, if there is no carry, it's stored in zero flag. If there is a carry, so like that, the status flag will be show what are the condition of the DSP architecture. And overflow management means if it is the data is getting overflowed, that they have the some limit that is indicated by overflow management. And register file, they have managing and moving the data and memory during the operation better speed. So they have to maintain and provide the register file. And the architecture and memory, so van Neumann architecture. So this is basic architecture, bus architecture and memory. So processor and memory, address and data. And this one is hardware architecture, processor, then program memory and data memory. So both are connected with address and data bus. And hardware architecture, the dual data memory. So the processor and program data memory. So here a dual data memory, so connected. So previously only hardware architecture, this one is having two data memory, that is called as dual data memory. And memory architecture comparison. So DSP architecture, hardware architecture, 2.4 memory, and then general purpose. So there are two kind of processor we are having, DSP processor and general purpose processor. So DSP processor, they're having hardware architecture, four memories access, and no cache on chip SRAM. But general purpose processor, they're having van Neumann architecture, typical one access cycle, and use caches. Okay, then thank you.